Have you ever looked at a set of numbers, maybe financial figures, and they seem pretty good on the surface anyway, but then you get that feeling, like there's something else going on, a hidden story underneath.
Yeah, like a puzzle piece that doesn't quite fit the picture you're seeing initially.
Exactly. Well, today, that's what we're diving into. How seemingly, let's say, favorable figures can sometimes mask, well, deeper, more complex stuff. Okay, let's unpack this one.
Sounds good.
So our mission for you today really is to cut through some of that complexity in performance management. We're focusing specifically on how companies track their material usage.
Right.
And we'll explore how those simple variances, the basic ones, can actually be broken down. And they can reveal some, well, pretty surprising insights into production decisions.
And the ripple effects, too. That's key.
Absolutely, the ripple effects.
And for this, we're drawing on some specialized articles, practical examples, to think things you'd find in, say, performance management syllabuses. It's really all about helping you understand not just what the numbers are saying, but why they matter, what they really mean for a business deep down.
Yeah, the why is crucial. Now, you might already know the basic idea of a material usage variance. Pretty standard stuff, right?
Yeah.
Did the company use more material than planned or less for what they actually produced? Simple enough. But where does it get really insightful? What's that next layer we need to peel back?
Okay, so here's the interesting part. When a company uses, more than one type of material to make something, which is pretty common.
Right. Most things aren't made of just one ingredient.
Exactly. That broad overall material usage variance, it can actually be split into two much more revealing components: material mix variance and material yield variance.
Okay, mix and yield. Let's clarify those. When we talk about mix, what exactly are we getting at?
So the materials mix, it's about the specific recipe, basically. The quantities and the proportions of each different input material used to make the product.
Like the ingredients list.
Pretty much. It's about what goes in. And the material mix variance, well, it compares the standard cost of the materials they actually used in their actual proportions to what it should have cost if they'd used that same total amount of material, but stuck to the standard planned proportions, the standard recipe.
Got it. So did they change the recipe ingredients effectively?
In essence, yes. And then yield is the other side of it.
That's about the output then. How much finished product you actually get out at the end.
Precisely. How much cake did you bake, to use an analogy? The material yield variance looks at the difference between the standard cost of the actual materials they put in.
Right.
Assuming they'd used the standard mix for that quantity.
Right.
Compared to the standard cost of the materials they should have needed to get the actual output they achieved.
So it's measuring how efficiently they turn those inputs into outputs.
Exactly. The efficiency of that conversion process. Did they get the expected bang for their buck material-wise?
Okay, that makes sense. And it's important to remember, right? If you calculate both mix and yield, you don't then also use the overall usage variance, because that would be like counting the same thing twice.
Absolutely. Mix and yield together are the usage variance, just broken down. You use one or the other level of detail.
But you should always keep the material price variance in the picture too, shouldn't you?
Oh, definitely. That's separate. How much you actually paid per kilo or per liter for those materials is another critical piece. Adds vital context.
Okay, good point. Let's make this concrete. Let's use an example. Imagine a company, let's call it Capico.
Okay.
They make a product called Omega, and they use 3 input materials: alpha, beta, and gamma.
Right.
And their standard planned mix is 40 kilograms of alpha, 60 kilos of beta, and 20 kilos of gamma. That's supposed to make 100 kilos of the final product, Omega.
And the costs are interesting here, too. Alpha is what, $2 per kilo?
Yeah, $2.
Beta is $5 per kilo. And gamma is just $1 per kilo.
So straight away, you see beta is the expensive one, by far.
5 times the price of gamma.
Now, here's where that managerial temptation kicks in, right? A production manager looks at this and thinks, beta is costing us a lot. Maybe they're tempted to, deviate from that standard mix.
Yeah, maybe use a bit less of that pricey beta, swap in some more of the cheap gamma, try and bring down the overall input cost.
Exactly. Seems logical on the surface.
But, and this is the big but, what's the trade-off? You change the mix, maybe you save cash on the inputs.
Yeah.
But what does it do to the final product? Does the quality suffer? And critically for our discussion, how much product do you actually get out? What happens to the yield?
Right, the hidden consequences. So let's look at what actually happened with Capico. This is where it gets really interesting.
Okay.
Their actual performance showed a favorable material mix variance, $913.33 favorable.
So they did change the mix.
They did. They successfully used relatively less of the expensive beta and more of the cheaper alpha, it seems. Saved money on the input side.
Looks good so far. A win for the manager, maybe?
You'd think so. BUT. And here's the twist. They also had an adverse material yield variance. 333 barlers adverse.
Ooh, okay. So despite saving money on the ingredients, so to speak, they got significantly less output, less omega than they should have expected for the total amount of materials they put in. The recipe change didn't bake as well.
Exactly. So what does this all mean when you put it together if you only looked at their overall usage variance?
Which is just the mix and yield combined.
Right. That overall number was actually $580 favorable.
Interesting. So a positive number overall.
Yeah. If you only saw that $580 favorable, you might think, wow, production did a great job, really efficient. Pat on the back time. But when you unpack it, using mix and yield, the story changes completely. It becomes clear that the positive overall number wasn't really from overall efficiency.
No, it was driven entirely by changing the mix of inputs to cheaper ones. And that change in mix, while saving money there, actually led to a lower yield. They produced less efficiently. The gain on the mix was bigger than the loss in the yield, but the yield did suffer.
It's a classic case of one number hiding the real story. And it also makes you wonder, doesn't it, about whose responsibility this is?
That's a really important question. Usually, production managers are responsible for the mix. They control what goes into the process day to day.
So they might be incentivized to make these kinds of changes. To show savings, maybe hit a bonus target.
That's possible, yeah. But the danger is if that cheaper mix affects product quality.
Which it might if you're swapping core ingredients.
And that could really damage the company's reputation. Long-term survival could be at stake, even if short-term costs look better. We should also quickly mention Capico's standards were apparently 5 years old.
That's relevant too.
Yeah, outdated standards could definitely contribute to variances, making them less meaningful, perhaps.
That's a good point. And these effects, they don't just stop at the production variance numbers, do they? There are knock-on effects, interdependencies.
Absolutely critical point. What's really fascinating, and maybe worrying, is how a perceived win in one area, like that favorable mix variance, can cause real problems elsewhere. For instance, say the cheaper materials are harder to work with or lower quality.
Okay.
That might mean the workforce takes longer to process them. Maybe there's more waste, more rework. So you could end up with an adverse labor efficiency variance.
So the saving on materials drives up labor costs.
Exactly. And potentially overhead costs too. If machines are running longer or need more maintenance because of the different materials, it's all connected.
And even bigger picture, what about sales?
Well, that's the long-term concern, isn't it?
Yeah.
If the product quality does dip because of that changed mix,
Customers might notice.
they might. And eventually, sales volumes could start to decrease. People stop buying or switch to a competitor.
Yeah.
And that hits profitability hard.
But the tricky part there is the timing, I suppose.
Right. Those lower sales might not show up in the numbers until a later period, months, maybe even longer down the line.
Which makes it really hard to connect it directly back to that original decision the production manager made about the material mix.
It does. The cause and effect get blurred over time.
Wow. Okay, so we've really gone on quite a journey today, moving way beyond just those surface level numbers, uncovering these intricate links between material mix, material yield, and the overall performance picture.
And seeing how a seemingly good variance, that favorable number, can actually be a bit of a red flag.
Yeah, hinting at deeper issues maybe. Things aren't always what they seem.
That's a key takeaway. Remember, knowledge is great, but it's most valuable when it's really understood and applied properly. Critical thinking is just so essential, especially now with so much information flying around.
Definitely.
Always question those assumptions. Look at things from different angles when you're analyzing performance. There's almost always more to the story than just the initial figures.
Absolutely. So as we wrap up this deep dive, what's the one maybe provocative thought you want to leave our listeners mulling over?
Okay. A challenge, perhaps. Think about your own world, maybe your professional life, or even personal metrics you track.
Okay.
Where might you have a metric, a number, an achievement that looks really positive on the surface? But could it be masking something? a subtle underlying trade-off, or maybe some longer-term consequences that haven't quite emerged yet.
That's a great question.
How can you apply this kind of holistic deep dive thinking we've talked about today to uncover the full story behind those numbers and ultimately make truly informed decisions?